Good day, everyone. My name is Christine J. Antonio Guzman, and together with my colleagues Jefferson Natividad and Cristina Ecrila, we are pleased to present our research project on the development of an online grading system for efficient and accurate student performance evaluation for BSIT2B BPO students at Isabela State University, Cauayan City campus. In today's educational landscape, grades serve as a crucial indicator for student learning and progress. As highlighted in our introductions, grades are essential for tracking student development, identifying areas needing support, and acknowledging achievements. However, the traditional method of manual grading presents several challenges. It can be time consuming for educators, prone to errors in computations and record keeping, and can sometimes lead to inefficiencies. Fortunately, the increasing integration of technology in education offers a solution. Online grading systems have emerged as powerful digital tools that empower teachers to input scores, automatically calculate grades, and securely store academic records. Furthermore, these systems often provide students with convenient access to their grades, fostering transparency and engagement. Numerous studies, including the work of Tuba and San Jose in 2019, have demonstrated the significant benefits of automated grading in terms of efficiency and accuracy. Recognizing the potential of such system, our research especially addresses the need for an efficient, accurate, and the user-friendly online grading system tailored to the requirements of Bachelor of Science in Information Technology, major in Business Process Outsourcing, BSIT-2B BPO, student Isabel State University, Cauayan City Campus. To address this need, our study was guided by the following key objectives. The first one is to develop an online grading system for BSIT2B students. Second, to evaluate the system efficiency and accuracy in grade computation and record keeping. Third, to assess the usability and accessibility of the online grading system for both teachers and students. The fourth one is to identify the potential challenges and areas of improvement in terms of performance, information, and data management, economics, control, and security, overall, efficiency, and service quality.
Now, let's move on to the methodology we employed in conducting this research. Our study utilized a quantitative research design. This approach allowed us to systematically collect and analyze numerical data to evaluate the effectiveness and usability of the developed system. For the development of the online grading system itself, we adopted the waterfall model. This sequential methodology involves distinct phases, which we followed. In planning and requirements gathering, in this initial phase, we identified the problems associated with manual grading and meticulously collected the specific requirements from both teachers and students to ensure the system would meet their needs. In system design, we focused on designing the structure of the online grading system. This included planning how grades would be efficiently entered, securely stored in a database, and clearly displayed to the users. In development, the actual creation of the system took place in this phase. We utilized technologies such as PHP for the back-end logic, HTML for the structure of the web pages, MySQL for the database management, and Bootstrap for a responsive and user-friendly interface, ensuring the system would operate efficiently. In testing, rigorous testing was conducted to ensure the system's reliability and accuracy. This involved inputting sample student grades, checking if the system correctly computed and displayed the results. In implementation evaluation, finally, the system was implemented for use by the BSIT-2B BPO teachers and students. Following its use, we gathered their verbal feedback to comprehensively measure its overall effectiveness and identify areas for potential improvement. To give you an idea of the technological foundation of our system, here are some of the key hardware and software requirements we considered during development. This table presents the minimum and recommended hardware requirements for the proposed system. The system runs on Windows 7, but Windows 10 or higher is recommended for better security and compatibility. It requires SAMP for web hosting, with the latest version preferred for improved security and bug fixes. PHP, HTML, and MySQL are essential for development, but Bootstrap enhances the user interface. MySQL manages student records. For access, Google Chrome is required, but the latest version is preferred for speed and security updates. Using the recommended software, it ensures better performance, data protection, and a smoother user experience. The table presents the minimum and recommended hardware requirements for the proposed system. The system requires at least an Intel Core i3 processor, but an Intel Core i5 or higher is recommended for better speed and multitasking. A minimum of 4GB RAM is needed, so 8GB or more ensures smoother performance, especially when handling large student records. The system can run on a 255GB HDD, but a 512GB SSD is preferred for faster data access and improved overall system speed. This use case diagram illustrates the primary interactions between the users, both teachers and students, and the online grading system. As you can see, teachers can perform actions such as inputting grades, calculating averages, and managing student records, while students can view their grades and their overall standing. The system architecture comprises three main layers: the user interface layer, which is what the users interact with, the application layer, which handles the system's logic and processing, and the database layer, where all the data is securely stored. Our study involved the participation of both the teachers and the students at the BSIT-2B BPO at ISU Kawayan. Their valuable feedback was crucial in evaluating the system's effectiveness and usability. The teacher serves as the primary user responsible for inputting grades, managing student records, and assessing the system's efficiency in computing and storing grades. Their feedback will help determine if the system reduces manual workload and improves grading accuracy. The students who will use the system to view their grades and track academic performance provide insight into the accessibility, ease of use, and reliability of the grading system. Their feedback will assess how well the system delivers real-time grade updates. To gather data, we primarily use a survey questionnaire distributed to both teacher and students. This questionnaire aimed to assess their perceptions of the system's usability, efficiency, and accuracy. Additionally, we conducted thorough system testing to identify and address any technical issues. In our data gathering procedures, we followed these steps. First, system development, creating the system using the waterfall model. Then, testing and evaluation, having teachers and students test the system. Then, survey distribution, giving the questionnaires to respondents for feedback. And the last, data collection and analysis, gathering and analyzing responses to determine the system's effectiveness. For the analysis of the survey data, we employed the statistical method of the weighted mean. This allowed us to determine the average level of agreement or satisfaction among the respondents regarding various aspects of the online grading system. And we used the Likert scale. Now, let's move on to the findings of our study and the corresponding discussion. Our respondent group consisted of 1 teacher and 30 students from the BSIT-2B BPO at the SU Kawayan. This chart summarizes the responses regarding the system's usability and efficiency. As you can see, the respondents generally indicated a positive perception of the systems like accessibility and ease of use, on which it reaches a 4.8 rating and it is the highest. The overall weighted mean suggests a positive and neutral evaluation in this area. However, some areas such as loading speed receive 3.2 rating. It indicates potential areas for improvement. These findings suggest that the system is generally user-friendly and efficient, which aligns with the benefits often cited for online grading systems. For instance, the high ratings for accessibility indicate that both teachers and students found it relatively easy to navigate and use the system. However, the feedback on loading speed highlights a technical challenge that needs to be addressed for optimal performance. Addressing our first research question concerning the system's efficiency and accuracy, our findings indicate that the online grading system significantly improved the speed of grade computation and record keeping. Teachers reported a noticeable reduction in time spent on this task, and the automated calculation minimized the potential for manual errors. This supports the findings of Tuba and San Jose 2019 and Khan et al. 2022, who also highlighted the efficiency gains of web-based grading systems. Regarding the second research question on user-friendly features, the positive feedback on accessibility and ease of use suggests that the system incorporates several user-friendly design elements. This aligns with emphasis on usability in the work of Gonzalez 2021, who underscored the importance of intuitive interfaces in educational technology. In response to our third research question about potential challenges, the feedback received pointed toward areas such as loading speed as a primary concern. This aligns with some of the challenges discussed in the literature, such as the technical performance issue noted by Selwyn. Other suggestions and comments also touch upon the need for mobile accessibility or additional features. We also gathered valuable suggestions and comments from our respondents, including the desire for mobile application like the enhanced AI and add more features. These insights are crucial for future system enhancements.
Finally, let's move on to our conclusions and recommendations. In conclusions, our study demonstrates the successful development and positive evaluations of an online grading system for BSIT-2B BPO students at ISU Kawayan. The system was found to be efficient and accurate in grade computations and record keeping. It was also perceived as generally user-friendly and accessible by both teachers and students. While the system exhibits significant potential, some areas for improvement, such as loading speed, were identified. Based on findings and feedback received, we recommend the following: optimize system performance, focus on improving the system's loading speed and overall responsiveness to enhance user experience, explore feature enhancements, consider incorporating additional features such as online assignment, submission grade distribution charts, an FAQ section, a calendar with deadlines, enhance user interface and user experience. Conduct further usability testing and gather more feedback to refine the system's intuitiveness and visual appeal. For future research, we suggest exploring the long-term impact of the online grading system on student academic performance and teacher workload. Investigating the correlation between system use and student engagement or conducting a cost-effectiveness analysis could provide further valuable insights. Additionally, a comparative study with other online grading systems could be considered. This concludes our presentation on the development of the online grading system. We hope that our findings and recommendations will contribute to the ongoing improvement and effective utilization of this valuable educational tool at ISU Kawayan. Thank you for your time and attention.